thought I'd go back and do some more problems from the Mod 18 part of the final review. Several of you seem to be having troubles with how to put that in writing. You may have watched Mrs. Franken's video, but you don't know how to show me what you just did. First of all, reference angle. She just did it by looking at the unit circle. And even if you have a unit circle, you kind of still need to put some stuff in writing for me. Okay, I threw in a unit circle here. We want to find a reference angle for 120 degrees. So first thing I want to know is, where is 120 degrees? If I look at the numbers on my unit circle, I can see that it's right here. Remember that reference angle is, how far is it to the nearest part of the x-axis? Well, this would be the nearest part of the x-axis. Trying to find this distance here. And since I'm at 120 and I'm comparing it to 180, the easiest way to show what I just did is to say, how far is it from 180 to 120? 60 degrees. Remember that reference angle is always a number between 0 and 90 degrees when you're talking about degrees. It can't be more than a quadrant, because if I measured this way, that wouldn't be to the nearest part of the x-axis. If I'm going to the nearest part of the x-axis, it's got to be less than 90 degrees. Let's look at another degree problem. This one is 310 degrees. I do not see 310 degrees. I see 300. I see 315. It's in there somewhere. But the point is it closer to 0 or 180 or 360? And that's the number you're going to use to subtract with. This one's close to 360. So 360, 310, that is 50 degrees apart. And that's your answer. Looking at it in radians can be a little bit more difficult or a little bit easier. If the bottom of the fraction is 2, 3, 4, there are no 5s on the unit circle, and 6, then you can just take pi over whatever that is. So if I wanted to show work for this one, I could just say, this is a 3, so I have pi over 3. This is a 4, so I have pi over 4. If I didn't know that little trick, then I'd be looking again at my unit circle, and I'd be saying, I'd be saying 13 pi over 4. I don't even know where 13 pi over 4 is. That's why I require that in general, if it's something you can't find on the unit circle, show me what it is. 0, pi, and 2 pi. I never put an equal sign here because pi is not equal to 2 pi. I saw some of you on your final review writing this. 120 degrees equals 60 degrees. Coterminal, yes. Nope, not even coterminal. Sharing the same reference angle, yes. But they're not equal to each other. So I would say that I have pi, but since I'm dealing with fourths, I'd say that this is 4/4 of pi, and this is 2 times 4, 8/4 of pi. And then I would take my 13 pi over 4, and I'd adjust it by taking off a full circle, 8 pi over 4, which still leaves me with 5 pi over 4. Then I could look at it on the unit circle and say, where is 5 pi over 4? 5 pi over 4, right in there. And then you can say, that looks like it's closer to 180, except that we're in radians now. So we're going to say, oh, it's over here somewhere. It's close to pi over 4. So I can say, how far is it from 5 pi over 4 to 4 pi over 4 pi over 4? So even though you're allowed to use the shortcut for the reference angle, you need to be able to know how to do that when they ask you for sine, cosine, tangent, because you'll still need to know what quadrant it is, what section it's in. But for this problem, that would have been enough work for it. If I'm looking at 4 pi over 3, I can find it right here. And then I can say, how far is it from 4 pi over 3? Let's look at our picture. If I'm talking about pi with a 3 on the bottom, that's 3/3, and double that and call it 6/3. Is it closer to 3/3 or is it closer to 6/3? 4/3 has to be right over here somewhere, a little bit past 3/3. And how far is it from here to here? A single pi over 3. But again, for these, when they're only asking for the reference angle, it's okay to say 3 on the bottom tells me pi over 3. It's okay to show that for your work, because that shows me. But just writing down pi over 3 does nothing to explain to me what you did. And you know, for the final review, I want every single problem to have something so that when you look at it later, you know what you did. There's some other problems. These. When Mrs. Franken did them, she just said, add 2 pi, subtract 2 pi, add. That's not a good plan when I can't see your calculator and you know what you did. So I'm thinking about something with 12s on it. So my pi turns into 12/12ths of pi, and my 2 pi turns into 12 times 2, 24/12ths of pi. Of course, it's also 0. And all of these choices have 12s on the bottom. So I start with the one that they give me, 23 pi over 12. And I'm going to say, are there any there that are bigger than 23 on top? This one, this one, this one. Those are bigger. So I will say, take that, add a full circle, which means add 2 pi. And 23 plus 24 makes 47 pi over 12. Yep. I went from 23 to 47 without passing through 35. Forget the 35. Then I'm going to take that answer and I have one that's a little bit bigger, so I'll add another full circle. But even before I add it, is there any way that 47 plus 24 is going to be 59? No. I started at 23 pi over 12. Is there anything else bigger than that? Nope. So now I'm going to look for things that are smaller than that by going back to the start, which was 23 pi over 12, and subtract a full circle. Subtract 24 pi over 12. I just went from positive 23 to negative 1. From positive 23 down to negative 1 without touching that one. And without even touching the positive 1/12. But I did touch this one, not the positive 1/12. I need to go a little bit more because that one's more negative. So now I'm going to take negative 1 pi over 12 and subtract a full circle to give me negative 25 pi over 12. and that is this one. That's how I determine all the ones that work. Now, I did that with common denominators. It would have been okay if I used my calculator, and instead of doing 24 pi over 12 here, if I said, what's 23 twelfths minus 2? And my calculator would give me an answer. I could have said, what's 47 twelfths plus 2? And my calculator would give me a fraction answer. But I still want you to show me on paper what it is you're doing. And what was this? I guess it doesn't matter what this was because it wasn't what we wanted. Let's do it again with degrees. Most of us have a better understanding of this in degrees. Starting with 240. And let's look at anything bigger than 240. Let's see, oh, hey, 240, 240. I think we can take that one. I have to look at all of those and see if it's possible to get through them adding just a full circle. You can't add 180. You can only add 360. $600. Yes. Take that. Add another 360. Oh, wait a minute. I went from 240 to 600 without ever touching 420. It's in between there, and I didn't get there. Cross that out. 0, 6, 9, 960. I went right past 780 without touching it. Get that guy. Go back to the beginning, and let's find things that are smaller than 240. Start with 240. Subtract 360. That is negative 120 degrees. I want that one. Wait, I just went from positive 240 to negative 360 without ever touching positive 60. Throw him out. And then I have negative 120. Subtract another full circle. Ooh, I went from negative 120 to negative 480 without touching this. But I did touch this. You see that this is the work I want to see. Mrs. Franken did this on her video, but she did it all on her calculator. And if there's nothing on your paper, I don't have any idea whether you really understand how that happened or if you just copied the answers with no understanding. I guess there's always the chance that you just copied without understanding. If you have something in writing in your paper, that means there's a chance that when you look at it later, you'll understand what happened, even if you didn't understand it at the time. Let's see if there's another problem here I need to do. Yeah, I think I need to do this section. Use a unit circle to find the exact value of each trigonometric function. And some of you turned in your final review, and all you wrote on there was, I used the wheel thing. Okay, even if you knew it was called a unit circle, that's not enough for me. If you have a number that is not between 0 and 360, or not between 0 and 2 pi, you need to show me how you located where it is on the unit circle. You could do that by drawing a picture and putting in the right number of spirals to see what's going on. To me, that is not the easiest way to do that. I'm going to do it with numbers. So I have negative 120, and I could look at the unit circle and say, I'm going to start here and go 120 degrees in the negative direction. Well, I know 120 degrees in the positive direction is a quadrant plus a third of a quadrant. So I could go a quadrant plus a third of a quadrant and know that it ends up right there. For some of you, visualizing it's best, and you could draw that picture and find it. For some of us, we want to do that coterminal thing and just say negative 120 plus a full circle takes me to positive 240 degrees. Then I can find 240 degrees, and 240 degrees is right here. And I want you to remember that when you look at the points on the unit circle, the x and the y points, the x is the cosine theta, and the y is the sine theta. Some people say sine is the y, cosine is the x, tangent is the y over the x. You need to know that for your tests, for your homework quizzes. You need to know that. So 240 degrees, and cosine means I want the x value. So I'm going down to 240 degrees and saying there's the x value, -1/2. That's my answer, but I'm not going to accept it if you just write it down. You have to show me how you located it. You can show me with those calculations, or you can show me by drawing this angle and figuring out what those coordinates are, writing down those coordinates and so on. Okay, let's look at this one. Now, 11 pi over 2 is not something you can easily see on your unit circle. So let's think about pi and 0 and 2 pi. And because this has a 2 on the bottom, I'm going to call this 2 halves. And 2 times 2, I'm going to call this one 4 halves of pi. 11 pi over 2 is more than a full circle. So if I wanted to think it through here, I could say it's a positive number, so I'm going to go up first. Just going to do it with a highlighter. And I can say, if I went a full circle around, that would be 4 halves, not enough. If I want another full circle around, that'd be 8 halves, not enough. There's 9 halves. There's 10 halves. There's 11 halves. There's where I'm going to end up. You can draw that spiraling picture to show what you're doing. You can draw that spiraling picture here by saying 4 halves, 8 halves, 9 halves, 10 halves, 11 halves. And you've got a starting ray, and you've got an ending ray. And then you can just look at what are the coordinates right there. Sideways 0, down -1. I need tangent, and I need to know that tangent theta is the y value over the x value. In this case, the y value is -1, the x value is 0. Anything with a 0 on the bottom, undefined. I always say that, but truth is, if you have 0 over 0, it's something else called indeterminate. Still, can't do it, but it means something different when you get to calculus. Okay, let's look at the next page. One more, because this year we skipped the secant, cosecant, cotangent stuff. I will probably still be posting this video next year. Don't automatically skip them. If this is past 2020, the year we were online, don't just skip them because I have them scribbled out here. You will need to do them. But Mrs. Franken's video does a decent job on those. So here I have another one that is not exactly between 0 and 360. It's -225. I could look at my circle and say 225 degrees is over here. It's a half a circle and a half a quadrant. So I want to do a half a circle and a half a quadrant. And put me right up here and know I'm going to use those numbers. If the drawing is the easiest way for you to show it, you can show it with a drawing. I think it's easier to say -225. Not a good number. Add a full circle. Why did I add instead of subtracting? Because it's too small. I want it to get bigger. If somebody gave me something like 5,000, I would have to start subtracting 360s until I can get it down to normal. So 225 plus 3, -225 plus 360. 135 degrees. And isn't that what I found by going the other way around? Not exactly, because my drawing didn't turn out perfect because I didn't look closely enough at it. It was supposed to be just half a quadrant, and I made it more like 2/3 of a quadrant. Those little things are the reason that I prefer the adding and subtracting process instead of the draw a picture process. But it's all up to you if you can do it well. So I'm looking at these numbers in here. And since I want the sign is the y value. And the y value at that point is root 2 over 2. Okay. I still want to see that work. Whether you show it on the circle or whether you show it by finding the number with adding or subtracting a full circle so that you can eventually find out where that is. If you didn't have the full circle, if you only had quadrant 1, you would take this 135 degrees we just got. You would say 135 is closer to 180. It's 45 degrees away. And then I can look at the numbers here for the 45 degree one, and I could say, after I've chosen the root 2 over 2, I could say all students take calculus. And knowing that I was in this quadrant over here, I would say only sine is positive. If they asked me for cosine, if they asked me for tangent, I'd get a negative. Sine is positive. This means all positive in quadrant 1. This means sine positive in quadrant 2. This means only tangent is positive in quadrant 3. And this is only cosine is positive in quadrant 4. And eventually, I hope that if you go on to take pre-calc, you will reach the point where you don't need to draw the whole thing. In fact, some people already are at that point where they can draw just the quadrant 1. That's all they really need to have memorized. And they can figure out the rest just by having a feel for which quadrant it's in. Okay, I hope that is enough for you to get through the rest of these problems if you're still struggling.